Hello my friends and welcome, my name is Dennis and this is the latest update on Alaska Airlines accident that happened to the Boeing 737 Max -9. As you probably know, I'm the Boeing 737 type-rated pilot, so here will be more or less my reaction on the events around this accident. So here's the press conference of the NTSB representatives. Those guys conduct the investigation of the case and they came out with the initial report about the case because they already decoded some of the flight data recorders, so it could be quite interesting. Let's listen to them.
At 17:06 and 47 seconds Pacific Standard Time, the aircraft departed runway 28 left at Portland International Airport. At 17:12 and 33 seconds, the recorded cabin pressure dropped from 14.09 to 11.64 pounds per square inch when the aircraft was at approximately 14,830 feet and 271 knots.
So we know the altitude when it happened, so more than 14,000 feet. It means that the oxygen mask would automatically drop in the cabin compartment. By the way, my friends, I expedited the video by 50%. I think we should expedite it even more. So let's go and listen.
Cabin altitude greater than 10,000 feet warning activated.
It's usual. You have the warning at 10,000, but oxygen mask drop after 14,000, so you have this gap of 4,000 feet of altitude to solve this problem and maybe descend lower just not to cause the panic in the cabin.
17:12 and 34 seconds, the master caution activated. The cabin pressure dropped to 9.08 psi at approximately 14,850 feet and 271 knots. At 17:12 and 52 seconds, the master caution deactivated. At 17:13 and 41 seconds, the aircraft continued to climb and reached a maximum altitude of 16,320 feet and began to descend.
So why do they continue to climb after this cabin warning? Well, the climb rate at those still relatively low altitudes is still quite high. Also, as humans, we have the reaction inertia, and yes, you follow the non-standard procedures every time during your flight simulator training, but still it's non-standard, your daily flight, and here you have boom and the cabin altitude warning. So I would say that the crew was quite fast, stopping the airplane just at 16,000 feet. Let's continue.
Was 276 knots. At 17:13 and 56 seconds, the selected altitude changed from 23,000 feet to 10,000 feet. At 17:14 and 35 seconds, the master caution activated for 3 seconds. At 17:16 and 56 seconds, the aircraft began a left turn from 121 degrees. The altitude was approximately 10,120 feet.
So they descended, and I believe that master caution was on for 3 seconds because they returned to their destination airfield, and if you haven't reached your set flight level, which is programmed for your flight, you'll have the master caution warning. It's a normal thing.
17:17, the aircraft descended below 10,000 feet. At 17:18 and 5 seconds, the aircraft altitude was approximately 9,050 feet, and the airspeed was 271 knots. The cabin altitude greater than 10,000 feet warning deactivated. The cabin pressure was 10.48 psi. At 17:26 and 46 seconds, the aircraft landed on runway 28 left at Portland International Airport.
Okay, I slowed down the speed a little bit because it's too fast for me, and the actions of the crew were done very fast from the pilot's perspective.
Now, the survival factors team interviewed the remaining 2 flight attendants, one from the aft of the aircraft and one from forward. Their interview and discussion was consistent with the interviews of the other 2 flight attendants. They also reported pretty significant crew communications challenges during the event. They didn't know what was occurring. They were certainly concerned, they stated, about the 4 unaccompanied minors, and their focus was on them and the 3 lap children at the time. The 2 flight attendants in the aft outboard seats in the aft galley had difficulty seeing what was going on in the cabin and in the aisle. It's very.
So the point that some of the crew members were not aware of the situation happening. So it seems like the pilots were a little in a rush because they had the cabin altitude warning and they didn't want to make any kind of the patterns. They just wanted to land the airplane. Well, as for me, maybe they should have made the passenger address and also called the flight attendants about what is actually happening, especially after descending to 10,000 feet, because here you have the normal pressure for everyone to survive for eternity, let's say. You have the unlimited time of the consciousness, but maybe pilots also wanted to land because they thought that maybe some of the passengers were injured and they required the emergency medical assistance, but in general there was no such a huge communication between pilots and the flight attendants from what I understood from her words. And you see that partially crew members were not aware of what was happening because they were at their seats during the takeoff. It was a normal climb. After that, immediate boom, descending and landing, so they also were quite concerned about the situation.
Difficult from that location to see anything. There is a very, very small mirror provided to look down the aisle. It's not sufficient. So it was very difficult for them to see. The flight attendants mentioned that the communications was so poor that they felt like they really needed guidance and information, and it was a pretty terrifying event.
Yeah, indeed.
Now, with that said, I know that a lot of media is reaching out to the flight attendants. The interviews have been very emotional. This was a really significant event with zero information at the time. There's a lot of trauma that they are working through. It's going to be a long process. It was terrifying. I would ask, the NTSB is asking, please give them that time. They are working with peer-to-peer counselors, and they just need that time to heal, and they have asked us to mention that in this media briefing, and I would really ask that you respect their wishes and give them that time to really begin to process what they experienced.
Okay, so I think it's not too much connected to their state in general, but she said that for the journalists to stop disturbing the flight attendants. It's the wise thing to say, so let's continue.
Now, the cockpit door. We found today that the cockpit door is designed to open during rapid decompression. It is designed to open during rapid decompression. However, no one among the flight crew knew that. They were not informed. So Boeing is going to make some changes to the manual, which then hopefully will translate into procedures and information for the flight attendants and for the crew in the cockpit.
So I actually know that you have panels in the cockpit door and they blow up in case of the rapid decompression. I wonder why the flight crew wasn't really aware of that. You may find actually this information in the Boeing document. For me, it is interesting whether those panels really detached from the doors in this case, because the cabin pressure ratio wasn't that significant at that relatively low altitude, because investigators didn't mention that.
As far as the oxygen mask, that we weren't sure if it deployed or if it was stuck, it did deploy. We interviewed the passengers in that row, and they had put the oxygen mask back up in the panel, which was the other thing we suspected, but it did deploy and was working. Now on to systems. Our systems group focused on the cabin pressure control system on the aircraft. This is the auto pressurization light that illuminated that we have gotten a lot of questions on. This system is designed as a triple redundant system with one primary cabin pressure controller. It's a computer system.
So she describes the pressurization system of the Boeing 737. I'm well familiar with that as well, so let's listen.
There is a secondary cabin pressure controller, that's a secondary computer system. And then there's a manual controller. So it's a triple redundant system. That means that if the primary controller fails, the flight crew switches to the secondary controller. If that fails, they can switch to manual.
Yes, and those controllers, they're identical and they change the operation after each landing automatically.
Any one of these systems is fully capable of maintaining safe cabin pressurization. In fact, if either one of the computer systems is inoperative, the FAA allows the operator to continue flying the aircraft.
Well, in that case, you should use the manual control, but it is not very precise and convenient, so you have to manually operate with main outflow valve, opening and closing the big hole at the aft part of the airplane. At the same time, pilots should pay extra attention on the table to correct the position of the main outflow valve. So here's the extra load on the flight crew. So I would say that you shouldn't fly like that for consecutive period of time.
Verified from the maintenance logs that the redundant system operated as designed on December 7th, January 3rd, and January 4th, going into the alt mode, not needing to go into the manual mode.
So one of those computers, she mentioned, wasn't working. So it was switched to the alternate mode operation, not the manual one. Still, the computer controls the pressurization of the airplane, so it's not connected to the door case itself. It is okay to fly like that with a single computer. It does not create the extra or significant pressure inside the airplane. No, everything of that was fine.
At this time, we have no indications whatsoever that this correlated in any way to the expulsion of the door plug and the rapid decompression. Now, the NTSB is very thorough, so we will go back and look at the flight data recorder, and we will get data on cabin pressure, and we're also going to download the memory on the cabin pressure controllers. We may have to pull the units to see why it was acting up, but at Boeing, we have asked Boeing for a specialist to arrive tomorrow to work through this, so we can just go through the rest of it. But again, no indication of any correlation between the two. With respect to the ETOPS restriction, Alaska Airlines reported to the NTSB that their internal policy is to restrict aircraft with multiple maintenance write-ups for certain aircraft systems from flying ETOPS flights for a period of time. That's not required by the regulation. That is an extra step that Alaska Airlines put in place.
So Alaska Airlines wants to strengthen the restriction of the ETOPS. ETOPS is applied for the twin-engine airplanes, mostly in cases that you fly outside of the landing fields for a very extensive period of time.
Now, ETOPS stands for Extended Twin Engine Operations. What that means is that ETOPS permits twin-engine airplanes to operate over a route that contains a point further than 3 hours flying time, 3 hours for this aircraft, from the nearest airport. And the restriction was put in place per Alaska as an extra step to ensure safety and to allow them to conduct maintenance. As for the structures, I want to start by thanking Bob, who all of the media successfully outed, but Bob apparently was a star with all his students today. I really want to thank the community overall. I can't thank you enough. Every time the NTSB asks for help. We did go out at 7 a.m. this morning to retrieve the door plug.
So I think they found the door and the door plug. It seems like also the phone of the passenger was found, which was sacked out from the airplane. So good advertisement for iPhones.
We are still looking for the bottom hinge fitting and a spring. It's a pretty large spring. The fitting is a green circular piece with a hole in it. It's not key to the investigation. This is not something that's key to us determining anything or ruling out anything. We're just fine. But it's always nice to have some of the pieces if you find it. And if anyone does, please call NTSB. Please email us at witness@ntsb.gov or contact local law enforcement. I will mention that community members also found today a plastic window frame and a headset and headrest, and turned that into the NTSB. So we really appreciate that. Thank you. Now, our structures team examined the right door plug. So the door plug on the left is what expelled the aircraft. They examined the right door plug in its installed position today and found no discrepancies. Everything was in place. Now, again, they examined it in the installed position. At some point, they may look at it in the position where you would conduct maintenance, which is 15 degrees down. That's still to come. Now, tomorrow, we also plan to do a 3D scan of the left opening and match it up to models and drawings to ensure that we're not missing anything. We're also going to send components and the door plug back to our lab in DC for further examination. Now, what we did want to provide to everyone today in real time is what broke. We are going to provide what broke. We cannot tell you at this time how or why. We do not have that information. We will have that information. It's going to take time, and we're going to have to analyze the components and the door plug in our lab to be able to figure out how this happened and why this happened.
So yes, indeed, the door plug just broke. She admitted it, but the reason is still unknown. So they have to deliver this door plug into the laboratory to check it for the metal fatigue and other possible things, maybe cracks or the defects that were made during the production of that particular door plug.
To allow Clint Crookshanks to go through that. Again, Leonie and Clint are the specialists here, and I think it's important that you hear it directly from them so you get the right information.
As you all know, the 737-9 has the provisions for a cabin emergency exit door in the aft fuselage. However, on this particular airplane, there was no door installed in that location due to the passenger seating configuration of the airplane. Instead, there was a plug installed in that opening. That plug is retained in the opening when 12 stop pads on the door frame interface with 12 stop pins on the plug to prevent the door from blowing out of the fuselage. In order to install that plug into the fuselage, you rotate it up so that the door or the plug stop is above the door stop. It translates inboard and then down so the stops then engage. At that point, 4 stop bolts are installed in the mechanism to prevent that plug from translating upward, disengaging those stops. There's also a guide roller on each side, on the upper side of the plug, or on the upper side of the door frame that engages with a guide fitting on the plug to establish the location in the opening.
Yes, it is kind of hard to understand the construction of this door. It looks simple, but in fact there are lots of the parts. Basically the plug there is to secure the door in the fixed position, and the door itself is pushed against the stoppers. Then the cabin pressure rises, so on the paper this door is very robust, and I don't recall any kind of the accidents or incidents involving those doors. Boeing used them for a very long time, since Boeing 707.
The exam to date has shown that the door, in fact, did translate upward. All 12 stops became disengaged, allowing it to blow out of the fuselage.
So they already found out what happened. The door moved a little bit up from the stoppers. There are lots of the stoppers around, and unfortunately the door was blown up by excessive pressure. So excessive pressure is supposed to stop the door from blowing up, but if it moves a little from the stopper's position, obviously it will go out with the help of the pressure.
We found that both guide tracks on the plug were fractured. We have not yet recovered the 4 bolts that restrain it from its vertical movement, and we have not yet determined if they existed there. That will be determined when we take the plug to our lab in Washington, D.C.
So plug is used to mainly secure the door. The stoppers are preventing the door from blowing up, but there are also some bolts, as he said, which prevent the door from moving up. So they already found the main piece of the information based on the debris and the plug which they found. The great question which he pointed out is whether those bolts are being installed in that door. Because again, it could be a human factor, because people are assembling those airplanes, people are working on the factories, they deal with hundreds of thousands of the airplane parts and tons of those bolts. After this briefing, journalists start to ask the question. One question was about those bolts and Boeing factory.
And then both airlines are finding bolts that weren't tight.
I think you don't hear what he says. Well, he asks if you are not sure whether those bolts were installed in that door, can we be sure that other critical bolts are installed in the airplane? Well, I think that I can reply on that. No, we are not sure whether all of the bolts and all of the stuff is fitted in the airplane correctly. It is as simple as that. Why? Because there is always a human factor. Humans made astonishing reliable stuff, but also humans make mistakes. You'll never get over it. It's impossible to make the solid and 100% safe system in any kind of the sphere where humans involved. You may say that we should switch to robots and artificial intelligence. Well, it comes in the future, but again, humans are responsible for that as well, programming the software and developing the stuff. We are not living in an ideal world, but there are some spheres of our life which are more safe than others, and aviation is the safest out there. What could be more safe? Nuclear power plants, but again, accidents happen there as well. So the journalist asked quite a philosophical question. I would suggest to put off the pink glasses. We do live in a non-perfect world. 100% safety is impossible to guarantee.
Right now, we are focused on the evidence. The evidence tells a story. The components on this door plug tell a story. We have to follow the evidence and see where it takes us before we jump to any sort of conclusions. We cannot speculate. We never jump to conclusions, but we don't speculate. We deal only with facts, and we're going to have to look at this aircraft. But again, we will go broader if we need to.
So again, journalists wanted to have some emotions about Boeing factory and stuff, and she is concentrating on this particular case, on those particular boats, because only those are involved, none of the other stuff. Okay, and then she speaks about the pilots. I think it's interesting to listen.
The question was on what came of the interviews of the pilots. So for the captain and the first officer, they described very loud environment, chaotic. At the time, they heard a bang and then some pressure changes in their ears. They mentioned that the door had flown open at the same time. A flight attendant had attempted to close it a few times, eventually succeeded in that. One of their checklists, their laminated checklist, flew out the door when the door also opened. They described it as very loud, windy at the time, and they had trouble communicating. They had trouble hearing each other. They had trouble hearing air traffic control, and they had trouble communicating throughout the event. I will say, once again, excellent job by the entire flight crew, those in the cockpit and those in the cabin, and also air traffic control.
So that is why there was lacking communication between pilots and the flight attendants because of this chaotic noise environment. So in this case, obviously, pilots should concentrate on flying the machine, flying the airplane safely. You said that they have the issue even communicating between each other. So if they try to address to the flight attendants or to the passengers, it would be like that. That's it. They focused on the task to land this airplane safely, so absolutely great job by the pilots. If you want to have more detailed explanation about the case with all of the schemes and where those boats are located or the plug itself, I would highly recommend you one of the best YouTubers who review the aviation incidents and accidents out there. His name is John and he has the YouTube channel called Blancaleria. I'll put the link for his channel and for this particular video in the video description just below. So my great recommendation to follow John, and he's more competent than me because he has more experience. He flown many of the different airplanes and for sure he knows what he says. He will show you on the pictures what happened and where are those stop pads and roller pins and other stuff of the door. He really goes deep into the explanation of every case that he reviews. In general, I think for you it's clear what happened there, and still we should wait for around 1 year for the final investigation result. As it usually happens with aviation investigations, my friends, I wish you all a peaceful sky wherever you are and have a great time.